The Hubble telescope has sent several incredible images of space since it entered orbit in 1990, but one of the greatest revelations came in 1995, Hubble Deep Field. What was that? How the Hubble telescope was built. Why did it take almost 20 years for space experts to launch the telescope? What challenges did they encounter before, during, and after the launch of the telescope, and how did NASA deal with it? All this and much more details about the Hubble telescope will be a part of this video, so stay tuned. Rome wasn't built in a day. To take up extraordinary challenges like launching the Hubble telescope, you must be ready for extraordinary challenges. But what were the challenges that put the whole project at risk? What were NASA's extraordinary Hubble mistakes? One of them was Hubble failed a focusing test. What did NASA do afterward? How did the organization save Hubble from embarrassing failure through its 5 repair missions 20 years ago? This video will explain it all in detail. Until now, there must be a number of questions popping up in your mind like, how did NASA come up with this project? How long will the Hubble telescope stay in orbit? And what will NASA do to the telescope once its lifespan is over? Well, these details will be explained first. Let us start right from the inception point of the Hubble telescope. In 1924, American astronomer Edwin Hubble used the 100-inch Hooker telescope on Mount Wilson near Los Angeles to study many galaxies other than the Milky Way. He observed several of them and found that they were moving away from each other, suggesting that the universe was expanding. In 1957, when the Soviets launched Sputnik 1, it started an era of the space race between the two superpowers as Congress passed the Space Act in 1958 and NASA was created. Later, in 1969, NASA started working on the Large Space Telescope after getting support from the National Academy of Sciences. In 1974, astrophysicists held their first meeting to discuss the working model of the Large Space Telescope. In 1977, Congress approved the funding and the project started. In 1978, the primary mirror grinding began, and in 1979, astronauts started prepping for the servicing mission. It was in the year 1983 when the Large Space Telescope was named after Edwin Hubble, the Hubble telescope. In 1986, an accident happened for which the space mission was halted for almost 32 months as Space Shuttle Challenger broke apart just 73 seconds after liftoff, putting a halt to any shuttle flights. In April 1990, Space Shuttle Discovery, carrying 5 astronauts and the Hubble telescope, was launched from Kennedy Space Center, and the telescope was deployed within 24 hours. The first image taken by the Hubble telescope was in May of 1990. In the next month, June 1990, a spherical aberration was discovered in the mirror. We will discuss this in detail later in the video. In 1993, the Hubble telescope discovered the exact age of the universe. There would be 5 further repair missions sent between 1993 and 2006. In 1995, the astronomer released Deep Field images. It was the most detailed view of the universe at the time, consisting of 342 separate exposures. In March 2022, the Hubble telescope broke its own record by detecting the light of a star that existed within the first billion years after the Big Bang. The star is so far that its light took 12.9 billion years to reach the Earth. Lens issues. Now, let's discuss the mistake that almost made the project an absolute failure. After its launch, it was expected that the Hubble telescope would produce mind-boggling pictures. Throughout its 30-year service, the telescope has taken millions of outstanding pictures. Despite being the most famous telescope, it's not easy to let go of the mistake that almost made the telescope an absolute failure. Soon after its launch, scientists discovered a major defect in the telescope's lens. This resulted in the telescope producing very blurry images. The 2.5-meter mirror is the core of the telescope. It must be in perfect working condition to produce images of the highest quality. The telescope has 2 mirrors. The main mirror captures the light before reflecting it into a much smaller mirror. From there on, the light reaches various imaging instruments of the telescope. If the mirror is curved perfectly, light can hit any part of the mirror and will focus exactly on the same spot. However, due to a defect in the mirror's curvature, the light falling in the inner part of the lens focused at a different place. The shape was only off by 2,000 nanometers. This isn't very much, Surprisingly, it was enough to render the Hubble telescope useless. How did the defect arise in the first place? The mirror underwent vigorous testing to ensure it could bear intense rocket vibrations in space. But, in order to test whether the mirror had been polished to the correct shape, they used the null corrector. The series of lenses were used to test whether the light hitting Hubble's lens was focused correctly. When engineers were testing it, one of the lenses was incorrectly placed, which canceled out the flaw. The results showed that Hubble's mirror was in perfect working condition. The Hubble telescope was finally launched with its inherent flaw. It didn't take too long for scientists to notice the flaw. The first image they received was blurry, indicating that Hubble was not working properly. For engineers, that was a crushing blow. After years of effort, perseverance, and investment, it looked as if the Hubble telescope would be remembered as the most embarrassing space project in the world. Well, Hubble was specifically designed in a way to be repairable. Located at the back of the telescope, there are 5 instrument bays. This arrangement means that instruments can be taken out and replaced by more advanced ones. So NASA came out with a compact set of mirrors that would take the light and refocus it. This new instrument was called a co-star. On December 2, 1993, the Space Shuttle Endeavour was launched. During their 7-hour stay in space, the 7 astronauts worked on replacing the defective instrument with co-star, and they did that smoothly and precisely. After a few weeks, when the Hubble sent new images, they were way clearer than the previous one, ascertaining the repair mission's success. 5 repair missions. Apart from this mission, another 4 repair missions took place between 1993 and 2006. Let's take a quick look at them. After the first servicing mission took place in 1993 and fixed the lens, the second servicing mission took place in 1997, and it installed the near-infrared camera, multi-object spectrometer, and space telescope imaging spectrograph. Following the spacecraft's gyroscope failure, the third servicing mission occurred in 1999. The primary function of the mission was to restore Hubble to working order and upgrade its systems. Astronauts installed a new computer as well as all new gyroscopes. The fourth servicing mission was conducted between March 1, 2002 and March 12, 2002. This mission was focused on upgrading the Hubble telescope. For the first time since its deployment, the telescope was powered down by controllers in order to change the power control unit. The fifth and final servicing mission was initiated in 2006, during which the astronauts would visit the telescope to extend its life. Now, let's discuss how the Hubble telescope could die. What could actually go wrong? With time, Hubble's orbit is slowly decaying, and it's estimated that the telescope will deorbit within a few decades. Chances are that an uncontrolled re-entry may cause some damage, including human fatalities. The Hubble Space Telescope contains 3 fine guidance sensors. This assembly is as old as the telescope. Currently, they're in good condition, but they're being degraded by the high radiation levels that Hubble experiences in low Earth orbit. So a failure in the telescope's communication system is one of the reasons which could end the life of the telescope. Based on radiation data and estimation, the telescope will re-enter Earth's orbit between 2028 and 2040. What is NASA's plan? Going up or going down? NASA has 2 options to safely end the life of the telescope. It can either deorbit it in a controlled fashion, or doom it over the Pacific, or boost it to a higher orbit to keep it afloat. There is still time to figure out the best possible solution. If NASA plans to launch a deorbiting mission, it would be unmanned, and raising the orbit requires a manned mission. In its last servicing mission, NASA installed a soft capture mechanism to enable deorbit of the telescope. Both SCM and Relative Navigation Systems, RNS, give astronauts multiple options to either extend or safely dispose of the telescope. Life expectancy and longevity. Now let's talk about the life expectancy and longevity of the Hubble Space Telescope. How long will it last, and what is NASA doing to extend the iconic telescope's lifespan? The successful repair and recovery operations are, of course, a cause of celebration, but it raises some pressing questions about the longevity and lifespan of the telescope. A telescope that's made up of decade-old hardware, how long will it last? Although some experts believe that the telescope is nearing its end, NASA is thinking the other way around. NASA's Goddard Space Flight Center is constantly working on patching up the software of the telescope to extend its lifespan. Another series of software updates are planned to make the telescope last long. NASA has recently launched the James Webb Telescope, and the telescope has made some astounding revelations about the age of the Earth and the existence of exoplanets. Well, the James Webb Telescope is not a like-for-like successor to the Hubble Space Telescope, but one can say that if Hubble expires after its illustrious record-breaking career, NASA still has a very powerful space observatory in its arsenal. That was a quick history, lifespan, revelation, and mission of the Hubble Space Telescope. We tried touching every aspect of the Hubble Space Telescope in this video, and we hope you enjoyed it.